Hey everyone, and welcome to today's Explainer. I am so incredibly pumped to have you here, because today we are embarking on a true masterclass about the hidden, invisible rules of physics that secretly govern the entire world around us. We're going to take the mundane, everyday things you see all the time and reveal the absolutely breathtaking science operating just beneath the surface. Today, we are decoding simple harmonic motion, the invisible rhythm of the world.
All right, here is our roadmap for today's journey. We'll be hitting 1. Everyday rhythms around us, 2. Defining harmonic motion, 3. The vocabulary of movement, 4. Equations of harmonic motion, 5. Calculating real-world rhythms, and finally 6. From guitars to earthquakes. And don't worry, the math we get into later is going to be completely grounded in the real world.
Okay, let's dive into this. I want you to close your eyes for just a second and imagine you're sitting on a playground swing. You push off the ground, you move forward, then backward. Forward again, and then backward again. Or, think about the pendulum of an old grandfather clock, just ticking left, then right. Have you ever actually stopped to wonder, why do these objects keep moving in this exact, repeating pattern? Like, what is the invisible force orchestrating this whole dance?
Section 1. Everyday rhythms around us. Observing the world's natural pulse.
You see, physics isn't just something locked away in dusty textbooks. It's alive. And it is quite literally all around us. Just look at these common anchors from our daily lives. A swinging pendulum, a playground swing, a vibrating guitar string right after you pluck it, a mass bouncing on the end of a stretched spring, or a tuning fork ringing out a perfect note. Whether you're plucking a guitar string or pushing a swing, you are activating the exact same repeating motion. They all play by the exact same rules.
Section 2. Defining harmonic motion, the rules of the rhythm. We're going to give this beautiful motion its proper scientific name.
We call it Simple Harmonic Motion, or SHM for short. The formal definition is that SHM is a periodic motion where the restoring force is directly proportional to the displacement and acts toward the equilibrium position. Now, I know that sounds incredibly technical, but let's strip all that jargon away. What's really interesting here, if we go back to our playground swing, is that it just means the swing moves back and forth repeatedly, and the further out you swing, the harder gravity tries to pull you back to the center. That's it.
Let's break these terms down so they're crystal clear. The equilibrium position is just the resting center point. If you stop pushing a swing, where does it hang? Right in the middle. That's equilibrium. The restoring force is that invisible pull back to the center. Actually, think of it like an invisible rubber band. Whenever you swing away from the middle, that rubber band stretches, and it pulls you back. And as you swing, kinetic energy, the energy of motion, and potential energy, stored energy, are continuously swapping places in this beautiful, endless dance.
Section 3. The vocabulary of movement, the terms we use to describe motion. Think of this next part as our toolkit.
We have 3 core terms to start with in our toolkit. Displacement is simply your distance from the center at any given moment. Amplitude is your maximum displacement. Think of our pendulum. If it swings out exactly 10 centimeters from the center before dropping back down, your amplitude is incredibly easy to visualize. It's exactly 10 centimeters. And finally, oscillation. That's one complete to and fro movement, out, back, and returning to where you started. One full round trip.
Now, we have 2 time-related terms that often get mixed up, but they are actually 2 sides of the same coin. Period, denoted by a capital T, is the time it takes to complete one full oscillation, measured in seconds, while frequency, denoted by a lowercase f, is the number of oscillations completed in one single second, measured in hertz. What's absolutely crucial to grasp here is the inverse relationship between the two. If a swing takes a long time to complete one back and forth motion, meaning a large period, it will complete very few swings in a single second, meaning a low frequency. So as period increases, frequency decreases.
Section 4. Equations of harmonic motion, the math behind the movement. Now, take a deep breath. We're going to the chalkboard, but do not let these equations intimidate you. Math is really just a language we use to describe the physical swing we've been talking about this whole time. Let's walk through this together. For example, F equals 1 over t perfectly shows that inverse relationship between frequency and period we just discussed. Or, look at the acceleration equation right there. See that negative sign? That beautifully proves, mathematically, that the restoring force is always pulling you backward toward the center, opposite to where you're currently going. And lastly, t equals 2 pi times the square root of L over g. This simply tells us the period of a simple pendulum depends entirely on its length and the force of gravity.
Section 5. Calculating real-world rhythms. Putting the equations to the test. Let's head into the lab.
All right, Welcome to our virtual lab. Here's a quick scenario to build some confidence. A simple pendulum makes exactly 5 oscillations in 10 seconds. We need to find its frequency and its period. Think back to the vocabulary toolkit we just learned. Let's move through this and see how it builds step by step. Step 1. Find the frequency. Remember, frequency is the number of oscillations divided by time. So 5 oscillations divided by 10 seconds gives us 0.5 Hz. Step 2. Find the period. The formula is T equals 1 divided by F. So 1 divided by our frequency of 0.5 gives us exactly 2 seconds. The pendulum takes exactly 2 seconds to complete one full swing. Very easy! You are basically a physicist now. Section 6. From Guitars to Earthquakes. Why Simple Harmonic Motion Matters.
So we've mastered the playground swing. Now let's scale things up. The really crucial point here is that this exact same principle, this simple harmonic motion, doesn't just apply to toys. It governs the waves in the ocean. It governs the sound reaching your ears. It's the core mechanism of all string musical instruments, like a guitar vibrating to create a chord. It's in the electrical systems powering your home. It's even describing the movement of invisible atoms vibrating in solid objects. And perhaps most awe-inspiring and, well, terrifying, when tectonic plates shift and send violent vibrations through the ground during an earthquake, that seismic wave is simple harmonic motion on a massive, destructive scale. It's just the ground oscillating back and forth from an equilibrium point.
Which leaves us with this final thought. Success starts with understanding. If you can understand the rhythm of a simple playground swing, you can unlock the hidden rhythms of massive earthquakes and microscopic atoms. The rules of the universe scale up and scale down, but the math and the motion remain beautifully consistent. So the next time you hear a guitar strum or sit on a swing, I challenge you, look for the equilibrium, feel the restoring force, and marvel at the hidden rhythm of the world. Because if simple math can explain an earthquake, what other invisible mathematical laws are secretly controlling the world around you right now? Thank you so much for joining me on this explainer, and I absolutely cannot wait to explore the next scientific mystery with you.